Hello, welcome to a new showcase for a new cracked optimization. This one saves around 3% of the overall code size, so this one is huge. Basically, what you do is you identify the most used variable in a thread, and instead of having it as a variable, you make it a register. What you have to do for this, you first have to make sure the GCC or whatever compiler you use doesn't actually use this register, and then you just define it like this. So on the gameplay thread, it's the current object. It's loaded a lot. On the graphic thread, it's the display list head. This is where all the graphics get stored to output them at the end of the frame. For the sound thread, I couldn't really find anything, so I just hard-coded the value 255, because the value 255 is used a lot on the sound thread. Basically what this does, if you wanted to store 0 to the current object's Y position, normally you would have to load the first half of the pointer, load the pointer from an address, and then store 0 to it. With GP relative addressing, which most hacks probably already have this, but you still have to add this to your game, you would just load the pointer relative to GP and then store 0. This saves one instruction. One instruction is like an eighth of a Dcache access, so it's like small improvement. But now, you just store it to the pointer, because the pointer is already loaded in. So this saves like 1 1/4 Dcache accesses over this, which is very good. Similarly, I have stored the value 1 into F30. Why am I storing 1 into F30? Why would you ever do that? Well, this is a floating point number, right? If you want to load the floating point number in GCC, what GCC is going to do, it's going to do like LWC1 F0 from wherever on GP, because it likes to just load directly from GP, which obviously that's going to be a Dcache access, so that's really slow. We have this crackhead function for this as well, this one right here. And if you use the CF function, let's say I would call CF1.f, I would get Louis 80 FreeF80. We all know FreeF80 is 1. If you didn't, then you know you do. And then just put it into F0. Which, you know, that doesn't cause a Dcache access. It's 1 line more, which, as I said, is an eighth of a Dcache access. So this saves you 7/8 of a Dcache access on average. Obviously, if your function is already a multiple of 8 instructions long, you don't want to do this, because then your instruction, then your function is going to be 1 instruction more. It's going to go into 33 instructions, which will be 5 Dcache accesses instead of 4. So you don't want that. So it's good to have both options. There's a GCC patch that makes every float generation from this into this, but we don't want that because of, you know, we want that option. But by storing it into a register directly like this, all of this vanishes into fucking nothing. This is all just gone. You can just use the value 1 right away. So that's amazing, because 1 is a very commonly used variable. And to set it up, you just kind of store 1 into F3 at the beginning of your thread. You just call setGP like this. And there you go. So I hope you enjoyed this. I'll be back with more optimization soon. See ya.